No longer mourn for me when I am dead, then you shall hear the surly sullen bell give warning to the world that I am fled from this vile world with vilest worms to dwell.
Those lines, gosh, from Shakespeare's Sonnet 71, they're just incredibly powerful, aren't they? I mean, to think of someone loving another that much, so selflessly that they'd rather be forgotten, just to spare their loved one pain, it's really moving. You can almost feel that conflict, that emotion he captured with just words. But here's the thing, the real mystery may be, how can we do that? How can humans express these incredibly nuanced, heartfelt things with such clarity? Thinking about, after-death contemplations or worrying about societal judgments. I mean, no other species gets close to that, right? Let alone talks about it. So our mission today, what we want to do is take a deep dive into exactly that question. How did our species end up with this extraordinary ability? Because let's face it, without language, there'd be no sonnets, no plays, no literature, no history, definitely no Shakespeare. It's just fundamental.
Well, absolutely. And it's even deeper than just communication. Language is, well, it seems fundamental to complex thought itself. There was the brilliant Soviet psychologist Lev Vygotsky. He argued pretty compellingly that our reasoning ability really depends, critically, on language. He connected speaking directly to how we even form mental concepts. And Noam Chomsky, the American linguist, he had a similar idea. He saw language as much a system for structuring our thinking, how we organize the world in our heads, as it is for talking to each other. I mean, think about it. When you're thinking, really thinking, you're often doing it linguistically, aren't you? Using words inside your head. Yeah, but here's the kicker. Despite how incredibly important it is, why human language evolved? Well, that's still one of science's biggest unsolved mysteries. And it's not like people haven't tried to figure it out. There are, dozens of ideas out there. Maybe it was for cooperative hunting, or like a fancy mating display, a costly ornament. Or perhaps it replaced grooming in bigger groups, or helped couples bond, or mothers talk to babies, even gossip, Could be tool making, maybe just a tool for thinking itself. But the trouble is, as our sources point out, a lot of these ideas are rife with speculation and teeming with plausible stories, but stories that are often, frankly, somewhat weakly supported by actual evidence.
Okay, right. Let's unpack that a bit. If there are so many theories floating around, why is this specific question, language origins, why is it so uniquely challenging? What makes it such a tough nut to crack?
Well, the core problem, and the source material really hits on this, is that it seems to have been a singular event. Think about it like this. Biologists studying, say, how a giraffe got its long neck, or an elephant that's trunk. They can compare them. They look at other animals with long necks or noses, or their evolutionary cousins. You can often see a sort of gradual progression. But with human language, there's just nothing remotely like it in the animal kingdom. Nothing to compare it to, really.
That's a bold claim, though. I mean, you always hear about the language of the bees, right? Or the chatter of dolphins. Don't those count for something?
Well, people have looked really closely at those. Intensive research, But honestly, no strong similarities to human language have emerged. And here's something even more surprising, maybe counterintuitive. When you look at primates, our closest relatives, their communication systems don't show this nice, neat increase in complexity from monkeys up to apes and then to us. In fact, sometimes great ape systems are more limited than monkeys.
Oh, really? Yeah. More limited. How so?
Well, for instance, some monkeys have these functionally referential alarm calls. Like one specific sound means leopard, another means eagle, really precise. Apes, generally, they don't have that kind of specific reference in their natural calls. And another huge difference is how little vocal communication is actually learned in non-human apes. It's mostly innate. Now, they do have gestures, like a baby ape might signal, "carry me," and those can have learned bits to them. But the gestures aren't really referential. They don't stand for things out there in the world symbolically like our words do. They're not conventional signs. Ape communication is typically just single, unrelated signals, and they can only be used in these really highly restricted functional contexts. They're almost never joined together to make more complex messages. And crucially, they can only communicate about the here and now. You won't catch an ape gossiping about yesterday or making plans for next week.
Ah, okay. That distinction really helps clear up that whole talking apes idea then. Because we've all seen the stories, right? Washoe, Cocoa apes, taught meaningful hand signs. And it's true, they could learn the meaning of a large number of signs and communicate using these. That part's amazing in itself, but as our sources really stress, there's pretty much virtually unanimous agreement among language experts that what they learned was not full grammatical language.
Exactly right. Take Nim Chimpsky, the chimp, famously taught sign language. His longest recorded sentence, if you can call it that, was, give orange me, give eat orange me, eat orange, give me, eat orange, give me you.
Wow. Give orange me, give me eat orange. You repeat it like that and it really hits you.
It does, doesn't it? You immediately see how devastatingly egocentric those attempts were. It's all just me, give, eat, immediate needs.
Yeah, totally focused on immediate gratification like a broken record.
Precisely. Now, contrast that with the typical 2-year-old human child. Just a few months after they start saying their first actual words, they're already putting together a variety of complex sentences. They're using verbs, nouns, prepositions, even little words like a and the determiners, all in the correct grammatical relations. And talking about all sorts of things. They can even talk about the past or the future or things that aren't right in front of them. It's just a completely different level of complexity and power. It's mind-boggling, really.
So yeah, it just highlights this massive evolutionary jump that must have happened.
Yeah.
Like the linguist Derek Bickerton put it so well, it's a paradox. Language must have evolved out of some prior system, and yet there does not seem to be any such system out of which it could have evolved.
It really is a paradox. And to get past just speculating, to actually evaluate theories properly, researchers have put together this set of 7 benchmarks. Think of it like a super tough checklist. It's compiled from work by people like Sabox, Zamato, Sathmary, and Bickerton himself, plus 1 more added by the author of our source material. And these criteria, taken together, they set a tough standard against which almost all of the proposed accounts fail.
Okay, 7 benchmarks. That sounds like a formidable challenge, definitely. Before we even hear about a theory that might pass, let's understand this mountain any Isaiah has to climb. If a theory can clear these hurdles, it must be onto something serious. What's the first big one?
Okay, the first hurdle is honesty. The theory has to explain why anyone would believe early language. Why trust it? See, in nature, signals are often costly to make them honest. Think of a peacock's tail. It's big, cumbersome, expensive to grow. It shouts, I'm fit. But human language. It's described as a uniquely economical and flexible signaling device. It allows for cheap talk. Words are easy to produce, right?
Okay, they don't cost much energy.
Exactly. So the big question is, why should anyone believe words if they are essentially cost-free to produce? A solid theory needs a context where there was no conflict of interest between the signaler and receiver, or at least one where you could easily check if the signals were reliable.
Huh, that's clever. Yeah, it seems backward that cheap talk would work. Okay, what's hurdle number 2?
Number 2, cooperativeness. Why would a speaker bother sharing useful information? Information that mainly benefits the receiver, especially if there's no guarantee of getting something back. This ties into honesty, making it even harder. We're not just making noise, we're sharing knowledge.
The why bother helping problem. Okay, number 3.
Third, it has to be adaptive from the outset. Language had to provide some kind of advantage right away, even in its simplest form. Remember Bickerton's 10-word test? What useful thing could you actually say with just, say, 10 words? It needed an immediate payoff, not some vague future benefit.
Right, it couldn't just be a maybe someday this will be useful kind of thing. It had to work then. What about the meaning? Where did the meaning of those first words come from?
Good question. That's number 4, being grounded in reality. This is the famous symbol grounding problem. How did words, these arbitrary symbols, get connected to actual things and actions in the real world? The theory needs to suggest how this happened, maybe through pointing, imitation, or some form of representation. A lot of theories stumble here, proposing early words that seem way too abstract, like implausibly abstract first terms.
Okay, so the words needed a concrete link to the world. Makes sense. Number 5.
Fifth is generality. Our language isn't just about the here and now. We talk about the past and the future, as well as events or objects distant in space. So a successful theory needs to explain how language got this power, how it generalized beyond immediate situations. This knocks out theories focused only on things like grooming or bonding.
Right, because those are pretty limited contexts. Okay, 6.
Sixth, and this is a really tricky one, uniqueness. Why humans? Why did language evolve in our lineage and not in other species, even other social primates? The specific circumstances driving language evolution must apply to humans and to no other species. Something had to be different about us.
The big why us question. Okay, and the last one, number 7.
And finally, 7th. Why did communication need to be learned? Human language is overwhelmingly learned. It changes rapidly through culture. That's totally different from non-human primate communication, which is largely innate and changes very slowly, if at all. So what was language for that made it essential for it to be both socially learned and rapidly changing? There's a hint here. Theory suggests that cultural transmission is favored in changeable and variable environments. Maybe our environment or our culture was changing fast.
Wow, okay. Honesty, cooperativeness, adaptive from the outset, grounded in reality, generality, uniqueness, and learned it. That is a tough list. Sounds like almost any idea will get knocked out by one or two of those, if not more. So is there any contender? Is there a hypothesis out there that actually manages to clear all 7 of these massive hurdles? Does anything solve Bickerton's paradox?
Well, this is where it gets really interesting, as you say. The sources we looked at propose a core hypothesis that, maybe surprisingly, seems to tick all those boxes. The idea is this. Language originally evolved to enhance the efficiency and scope of teaching, and specifically teaching close relatives.
Language for teaching, huh? Okay, that feels intuitive somehow. Not just passing on info, but the act of teaching itself driving language. How does that connect with, the bigger picture of human evolution?
It connects incredibly well, actually. It ties into concepts researchers call cultural drive and cumulative culture. The idea is that our ancestors got really, really good at social learning from each other with high fidelity. This led to cumulative culture, where innovations and skills build up over generations. Think about tool technology getting gradually better. And this cumulative culture, in turn, created a strong pressure for teaching. It's worth pointing out teaching is rare in nature, but universal in human societies. We're compulsive teachers, almost.
That's a really key difference, isn't it? We teach constantly. So why is language so perfectly suited for that job?
Well, for a few crucial reasons. First, it's incredibly cheap, energetically speaking. Think about it. Telling someone where to find a food patch is far easier than taking them there. Or warning a child, those red berries are poisonous, is much simpler and safer than letting them learn by trial and error. Even a simple yes or no or stop provides guidance at very low cost.
Right, much easier than dragging them around or demonstrating everything physically.
Exactly. Second, it's exceedingly accurate. Language brings a precision, virtually impossible to achieve through any other means. Think about simple teaching cues we use all the time. Pay attention, dig here, no, like this, faster, this way. That kind of specific feedback greatly enhances knowledge transfer.
Yeah, you can pinpoint exactly what needs changing.
And third, it extends the range of what can be taught. Language lets us teach abstract concepts, rules, things about the past and the future, and about events or objects some distance away. You can't easily demonstrate yesterday or over the next hill without words.
So cheaper, clearer, and broader knowledge transfer. That paints a really vivid picture. What does this imply about the specific evolutionary setting? Like where and when might this have started?
Well, picture our ancestors, maybe around 2 million years ago. They're living in small, kin-structured groups. They were likely cooperative breeders, meaning it wasn't just mom raising the kids. You had allo-mothering helpers, maybe fathers, grandparents, older siblings chipping in. And humans have this unusually long period of juvenile dependence. Kids need care for years and years. This long childhood makes teaching much more economical, evolutionarily speaking. The cost of teaching is offset because you're investing in someone you'll be supporting for a long time anyway.
Okay, so the social structure was right.
And critically, there was plenty to teach. These early hominins, like Homo habilis, had a broad omnivorous diet. They relied on complex skills, extractive foraging, like jigging up tubers or cracking nuts, and tool use. This was the very dawn of cumulative culture, starting with those first stone tools. The stage was really set for teaching to become super important.
Right, there was valuable, complex stuff that needed to be passed on.
Yeah.
Okay, now for the moment of truth. Let's put this teaching hypothesis up against those 7 criteria. Does it really hold up? Let's start with honesty. Why would language used for teaching can be honest?
Well, if language first evolved for teaching your kids or your grandkids or siblings, we would indeed expect it to be honest. Think about it. There are no new conflicts of interest introduced here. Passing on accurate knowledge directly helps the tutor's inclusive fitness. That's the evolutionary success of their shared genes. Lying or giving bad instructions, that's just a waste of a parent's time and effort, and it harms their own genetic legacy. So, strong pressure for honesty.
Right. Okay, that makes evolutionary sense. It's in your own genetic interest to teach well. What about cooperativeness? Does that follow easily?
Absolutely, it's readily understood. Teaching is fundamentally already collaborative. The tutor benefits by improving their relative's life skills, which, again, boosts the tutor's inclusive fitness. The act itself is cooperative. It's built in.
Right. Okay, so that brings us to being adaptive from the outset and being grounded in reality. How does the teaching idea handle those two? They seem tricky for other theories.
Actually, they become easy to envisage in a teaching context. Think about those very first steps. Simple cues, maybe attention-grabbing sounds, simple vocalizations, but crucially, combined with pointing, gestures, actions, demonstrations. These actions would ground teaching utterances to provide meaning to unfamiliar terms. Imagine a parent saying, "here," while pointing exactly where the kid should hit a stone core, or miming the motion of dig while saying a simple word for it, or saying no this way while physically guiding the child's hands.
I see. The meaning is literally tied to the action or the object right there.
Exactly. And developmental psychologists see this all the time. Adults naturally use these kinds of cues to help babies learn language. It provides an immediate practical benefit from just a few simple words combined with actions. It passes that 10-word test.
Okay, so grounded and useful from the start. What about generality? How does teaching lead to talking about the past or future?
There's a natural link there, too, within the teaching context. Language used for teaching practical skills, complex things like extractive foraging procedures, food processing methods, and hunting skills, naturally extends. Think about the diet of Homo habilis and Homo erectus. It relied more and more on processed, nutrient-rich foods, which likely required more complex skills and thus more teaching. It's easy to see how you'd go from teaching coordinated foraging actions in the present, like hit it here now, to planning future actions tomorrow, we go there to dig. Teaching about how easily leads to teaching about when and where. It makes those first abstract steps quite natural.
That's a really compelling pathway. Okay, now for maybe the toughest one, uniqueness. Why humans? Why didn't chimps, who also live in groups and use tools sometimes, evolve language if teaching was the key?
This criterion is also readily met, according to the hypothesis. The argument is simple. No other animals, aside from humans, and perhaps their immediate hominin ancestors, evolved language because humans alone were engaged in extensive teaching. And why were humans teaching so much? Because, the theory goes, only humans possessed cumulative culture to the degree we do. Culture that builds on itself generation after generation demands effective teaching to be passed on.
So the cumulative culture came first, creating the need for teaching, which then created the need for language.
Precisely. Without that widespread, complex teaching driven by cumulative culture, there wasn't the same strong selection pressure for those language traits that make teaching easier and cheaper. So language teaching and cumulative culture likely co-evolved in a runaway autocatalytic process. They spurred each other on in a feedback loop unique to our lineage.
A runaway process. I like that. A kind of self-reinforcing spiral. Yeah. Okay, and the last criterion. Why did language need to be learned, not just innate?
This ties back to that cultural evolution. Our ancestors weren't just passive recipients of evolution. They actively constructed the environmental conditions that favored hominid reliance on culture. This is called niche construction. We shaped our own evolutionary pressures through our behavior. Think about human cultural practices, tool-making, foraging techniques, shelters, eventually art, rituals. All this stuff diversified and grew in complexity incredibly fast, much faster than biological evolution could keep up with. This rapid cultural change required constantly updated and elaborate communicative signals and meanings. Language needed to be flexible, learnable, and rapidly adaptable to keep pace with the changing cultural world it needed to describe and teach. You can't biologically hardwire instructions for technology or social rules that are constantly evolving. Learning was essential.
This teaching hypothesis also seems to weigh in strongly on that old debate. Is language a specific adaptation or more of a side effect, a spandrel, like Chomsky suggested?
It definitely does. It strongly supports the view that language is indeed an adaptation. And specifically, it's an adaptation that functions to increase the accuracy, reduce the costs, and increase the scope of teaching. It gives language a clear functional purpose right from the start.
Okay, that theoretical framework is really coherent. It seems to fit all the criteria. But theory is one thing. Is there any more concrete evidence? Let's try and bring this to life.
Well, there's a fantastic experiment described in the sources that does just that. It provides really direct evidence that a specific complex skill, one definitely practiced by our ancestors, would have created exactly this kind of selection pressure for better teaching and potentially language. And that skill is stone tool making.
Oldowan tools. Napping flint.
Exactly. Oldowan technology, basic chopping tools, and flakes. Hominins were doing this for well over 2 million years. And it wasn't just banging rocks together, it involved systematic flake detachment. It required considerable practice and crucially seems to have been socially transmitted. Learned, not innate. This makes it a perfect test case for looking at the coevolution of toolmaking, thinking, and communication.
So how did they test this?
It was a pretty large-scale experiment, actually, led by Tom Morgan and Natalie Uomini. They had nearly 200 people try to learn Oldowan napping, working with over 6,000 pieces of flint. They set up 5 different learning conditions. One group just got the finished flakes and had to figure it out, reverse engineering. Another group could watch an expert make the tools, imitation emulation. Then, basic teaching, where the expert could demonstrate, slow down, even physically guide the learner's hands. Next, gestural teaching, allowing pointing, miming, any gestures except speech. And finally, verbal teaching, where the expert could talk and explain everything.
Wow, okay. That covers the main ways you could imagine the skills being passed down. So what happened? When the results came in, what did they show? Any surprises?
The findings were described as remarkably helpful, and they were really clear-cut. The bottom line, teaching in language, but not imitation or emulation, enhanced the acquisition of stone napping skills. People just watching or trying to copy the finished product, they didn't really improve much over baseline, but as soon as you introduced teaching, performance shot up. The quality of the flakes generated showed clear improvement with gestural or verbal teaching. Language, in fact, nearly doubled performance relative to reverse engineering, but imitation alone showed no improvement.
Double performance with language compared to just looking at the rocks.
And it gets better. Verbal teaching significantly outperformed gestural teaching across 6 different measures. Things like how many good usable flakes they produced per minute or the chance of a successful flake coming off with each hit. Gestural teaching roughly doubled success per hit compared to imitation, but verbal teaching quadrupled it.
Quadrupled. Okay, that's not a small difference. That is huge. It makes you immediately think about that long period, like 700,000 years, where Oldowan tools seem to have stayed pretty much the same. Could this experiment help explain that stasis?
It really suggests a powerful explanation, yes. The study concluded that teaching, but particularly teaching through the use of language, therefore greatly facilitated the rapid transmission of flaking, whereas there is little evidence that imitation or emulation did so. They also looked at transmission chains, like a game of telephone, but with tool making. Performance dropped off quickly in all conditions as skills were passed from person to person. But without teaching, the drop in performance was so severe that performance immediately fell to baseline levels. Innovations just wouldn't get passed on. Teaching, however, especially verbal teaching, allowed for much more stable transmission across generations in the experiment.
So without teaching, especially verbal teaching, any new clever idea would likely just die out.
Pretty much. The implication is that Oldowan technological change could well have been restricted by the fidelity of social transmission. Imitation was just too slow and imprecise for innovations to be conveyed reliably. The technology literally couldn't get much more complex until communication got better. This really boosts the idea that the next stage of tool technology, the Acheulean hand axes that show up around 1.7 million years ago, their spread probably would have required a capacity for teaching at least equivalent to the basic teaching condition in the experiment, and maybe more plausibly, a form of gestural or verbal proto-language. The study shows exactly how teaching could meet Bickerton's 10-word rule. Simple cues like "no, this way," or pointing and saying "hit here" provide immediate, useful guidance for a complex task.
It really paints that picture of the tools almost waiting for language to catch up, doesn't it? It beautifully reinforces that idea you mentioned earlier, the gene-culture co-evolutionary dynamic.
Exactly. Tool use creates pressure for better communication. Better communication allows for more complex tools and skills, which then creates pressure for even better communication, this perpetual cycle.
A virtuous spiral.
Right. And again, it's crucial to remember language probably didn't evolve just for tool making. It evolved for teaching all sorts of essential life skills. Tool making is just one really important and experimentally testable example of that broader need.
And the experiment also showed how language starts to become more general, moving beyond just simple commands. How did that work?
Well, it allowed the transmission of more abstract concepts needed for skilled napping. Things like understanding the platform angle, a technical idea about how to strike the core correctly. Language helps break down a complex task into meaningful parts, provides labels for concepts, and gives learners a clear framework with which pupils can go on to teach others. So it doesn't just help you learn the skill, it makes you a better teacher of the skill too.
Ah, it improves the transmission itself.
Precisely. And while other ideas exist, maybe language helped coordinate group scavenging or collaborative hunting, ideas from people like Bickerton again, or Michael Tomasello, the teaching hypothesis suggests that the fundamental need was teaching kin. Once language started evolving for that core purpose, it could then easily be co-opted and generalized to these other cooperative activities. Teaching was the seed.
Okay, so wrapping this up, what's the big takeaway here? This deep dive seems to point towards a really clear and quite compelling picture.
I think it does. The main takeaway from these sources is that language originally evolved to teach, and specifically to teach close relatives. And what's really powerful is that this single idea seems to uniquely pass all 7 of those incredibly strict criteria we discussed.
It ties together our unique social structure, our long childhoods, our reliance on complex skills, and our capacity for culture in a way other theories haven't managed.
Exactly. It suggests that our unique human language stemmed, fundamentally, from our unique ability to construct a sufficiently diverse, generative, and changeable cultural world that had to be talked about. Our hands and our culture created problems that only our voices could solve efficiently. Now, does this solve every mystery? No. Big questions remain about the specific brain mechanisms, those generative computations that let us create endless sentences, or exactly how words hook onto meaning, the semantic representations, and the evolution of vocal learning itself is still debated.
Of course, there are always more layers. But still, what a profound shift in perspective. It makes you think of someone like Alfred Russel Wallace, right? Co-discoverer of natural selection. But he famously struggled to see how something as complex and seemingly perfect as language could possibly evolve through natural selection alone.
Right. He thought it must require some other influence. But this teaching hypothesis provides a plausible, step-by-step evolutionary pathway driven by selection pressures our ancestors created for themselves. It really makes you consider how our ancestors, just by living, by making tools, by raising their young in cooperative groups, by building this increasingly complex cultural world, they literally created the necessity for learning, for teaching, and ultimately for language.
The kind of bootstrapping process.
Exactly. And it leaves you wondering, what other really fundamental human traits, things we take for granted about ourselves, might also be explained by these kinds of unexpected self-reinforcing dynamics between our biology, our behavior,